Hi everyone. Today I want to talk about my precedent for the topic for interpolation search. My name is Rong Feng, and this is my Drexel email address. And for the interpolation search, I want to talk about this algorithm running time, how this algorithm works, and code for this algorithm. Here is the running time about the interpolation search. We have the average running time is big O log n, and the worst case is big O log n. Why we have the two running times? Because we have the worst case. The worst case is unbalanced array, from one the element in array is to 1 to 3, and we jump 3 to 2000, like something that, and we want to find a specific number in this array. We will have the worst case. But the average runtime is this. This is better than the big O log n. And here I have an example to let you guys know. Here we have the mid formula. This formula is totally different to the binary. The binary formula. Binary formula just have about the high minus low. So we got the mid, and actually we just separate the whole array from the high to the low for the binary part. But this part we update the formula. The formula we have the low plus the key is what we want to find. What we want to find minus the low in this array divided the highest element minus the lowest minus, and the multiple the high minus low. So in this case, in this example, we want to find 5,555. So we have the mid of this array is 0.66, and in this position we only have the integer, so we have 0. The 0, so the index is 0. So we count from the index 0 is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 times to search through the 0 index to what we want to find. So I think you guys is already noticed that this example is the worst case, because we jump through 2 to 2000 is a huge gap between two numbers. So what we found the mid is just from it's near like the beginner. So we need to through the first one go through over the whole array to find what we have. So this one is worse. But if we use binary search about this array, that is easy, because we only have we have 12. So 1, 2, 3, 4, 5, 6. So actually we can find 2003, and we know the 50 and 500 5,555 is bigger than 2000. So we find the right side about this, and it's 2004 is 5555. So we find here. So in this case, the binary search is better than the interpolation search. But if we have 0, 1, 2, 3, 5, 9, 10, like we have this array, we use interpolation to find 9. That is easy, because we may have the 3 or 5 to our middle. So this one we make this easy. But I want to use this worst case interpolation to let you this array to let you know what is the worst case about the interpolation array. And here, this is the code. The code is C programming language, and we have initial two values. The first is for the lowest of this array, and the second is for the highest of this array. And the two argument is an integer array and an integer for what we want to find. For this, we have a while loop. The while loop is doing first count the middle of this array after what we want to find, and if the middle is smaller than the low and or higher or bigger than the upper, so we will break because this array doesn't exist, so we can't do anything about the wrong array. So we break and we return -1. We know, oh, we got this situation. And if the find is smaller than the middle, we know we will have the left side of the middle, and the upper is equal to middle -1, because we want to go through like this direction to find what we find. And they have the same logic. When the find is bigger than the middle, we up the low, and mid is to mid the low equal to mid +1. We just use this direction to find what we find, and then if the find equal to number mid, so we can return the mid, and that is the index of mid. That is what we want. So this is the basic logic about the interpolation search in C programming language. And thank you for watching. And this is the reference. Thank you for watching again. Bye.